problem with errors in writing our code, and some of the errors we come across are simply syntax errors or typographical errors. In this particular piece of code here, I have a problem equals 5 times 7 as a string and solution equals 35, and I want to print those out so that would say the answer to 5 times 7 is 35. But I get an error here called unexpected EOF, and EOF means end of file, while parsing. And the problem there is I forgot the last parenthesis. Remember, for every left we need a right, there's 2 left but only 1 right. And that would be a syntax error. That's a problem with my code, something that I typed in wrong. And we see those syntax errors before the program will even run. We get that error message that we see there as a dialog when we try to run the program. And then we have logic errors. And logic errors occur when our program runs and everything fine. It doesn't crash, doesn't give us an error, but we don't get the results we're expecting. And that's usually a problem with how we designed the program, or it could just simply be a little typographical error or a lapse in thought as we were typing this in. So here's an example. num1 equals 5 and num2 equals 7, and what I want to print is the product of 5 times 7 is 35. And so I use placeholders 0, 1, and 2, and my formats method of num1 going into 0, num2 going into 1, and num1 plus num2 going into 2. And the result is I get the product of 5 times 7 is 12. So I'm getting a logic error. I'm not getting the results I expect, which would be 35. And of course, the reason, if you haven't caught it, is I used a plus sign rather than an asterisk for multiplication. Everything works fine, I just don't get the results I expect. That's a logic error on the part of the developer. Well, in this lesson, we're going to deal with exceptions. And exceptions are runtime errors. It's an error that occurs while a program is running that typically crashes the program. And it's a result of an unexpectation, often the result of bad input. And that input may come from the user. It might also come from reading data in from a data file or a database. You've probably heard the term GIGO, garbage in, garbage out, G-I-G-O. And so we need to make sure that the data that the user is entering in is correct or in the right format. And if it's not, it might result in an exception. So if we don't properly handle our exceptions, then our program will crash and we'll get a message that might be confusing to the end user. Let me show you an example. So here I have a program and I have a main function. We have a sentinel value called again, which is a Boolean expression equaling true. And then while again, so while again is equal to true, I'm going to print the program will perform a simple division operation. We're going to have the user enter 2 values, and then we're going to divide those and then print the results of the division as well as the integer division and the modulus operation. And then we'll ask the user if they want to continue on and do another operation. And if they type in an n, we'll end. Otherwise, we'll repeat the process. So let me just run this. And so I'm asked to enter a dividend as an integer. I'm going to put in 7, and I'm going to divide that by 3. And the result is 2.333 is my regular division, but my integer division is 2. 3 goes into 7 twice, and my modulus operation, the remainder, is 1. 3 goes into 7 twice, but 1 is left over. I'm just going to press enter and do another one. Here I'll say 16 and divide that by 5, and I get 3.2. Integer division would be 3. 5 goes into 16 3 times, and 1 is left over. That's my modulus remainder. Let me do it one more time. So I'm going to do 16, and here I'm going to type the word 5, and I get a traceback error. And it shows me where that error occurs, which line. But let's look at the very last line of that red text there. This is a value error. An invalid literal for int with base 10. And it shows me that it didn't like the value 5. So that's one type of error, a value error. Let me run this again, and I'll show you another error. So I'm going to take 5 and divide by 0. And here I get a 0 division error, and the message I get is division by 0. So in both these statements, value error and 0 division error is my error type, and then it has a message. Invalid literal for int with base 10, or division by 0. That's my error message or exception message. So in both cases, though, they crashed my program. I don't have a chance to continue on and maybe try putting in something other than 0 or not typing out the word 5. Let's look at how to fix that, and that process is called exception handling. So I've modified my program a little bit from where it was before, in that I've added a try, except, else structure. Very similar to what we see in our conditional structures, like an if, elif, else. This is a structure for exception handling. And so in the try fork, I have what I want to try. So again, we're going to get the two integer values from the user and place those into x and y, and then divide x by y and place that into z, just as we did before. But if there's a problem with any of those, so if we try to put in the word 5 for y, as we did before, we would get that value error. That is an exception. If I try to divide the value of x by 0, that would be a 0 division error. That's also an exception. If an exception is thrown in the try fork, it then executes the except fork. And here I have except. It's going to do any exception, and I'm going to treat it as error. And that's just a variable I came up with. I could have named it Fred. But what I print here is 00, and then a placeholder 0. That's going to be our 0 division or our value error. And I'm going to print the error message. That would be the division by 0 or invalid literal. So if there is an exception, then it will continue executing and ask us to continue on. If there is no exception, if I put in a 3 and a 2 and this all works okay, it's going to skip the except and run the else and show me the results. So again, I'm going to run this. I'm going to put in 7 and 2, and the result is 3.5. Integer division is 3, and modulus is 1. That all worked great. Now let me make a mistake again. So we'll run this again, and this time I'll put in 16, and I'll put in that word 5, and the program doesn't crash any longer. Instead, I get this 00 exception fork running, and the type of error is a class value error, and it says error occurred, and then my error message is invalid literal for int with base 10, and it shows me the problem is the word 5. So I get the same information that I got before. It doesn't tell me in this case the line that it occurred in, but it does give maybe a message to the user without crashing the program. Now we can write a different message here than using the exceptions type and the exceptions message, but at least I can continue on. It doesn't crash my program. And so again, if I did 6 and I did a 0, now I'm getting a class 0 division error, and the error message is division by 0. But again, it hasn't ended my program. I can continue on, and so maybe I do this time 16 and 5, and I get a fine result. So I want to go back and look at these two different error messages. We had the one that was a value error and one that was a 0 division error. And we can handle those specifically. We can make except forks for each of those specific exceptions and maybe print a better message to the user that might be a little less confusing. Let me show you another variation of this program. I'm going to go ahead and end. So here then is yet another version of this program. And whereas we had in our conditions, we had an if, we could have several elifs and an else. Here I can have a try and several except forks and an else. By the way, I'm not required to have an else fork, but what's in the else fork is what's executed if no exception occurs. So it would be the result of my normal process. So here I've added an except value error. That was one of the errors we saw. And in that case, I want to print you did not enter an integer value, try again. If we get a 0 division error, then I'm going to print the divisor cannot be 0, try again. So I'm changing the message that's being displayed rather than just that standard error message. I want to provide something that's a little more pertinent to the operation that we're trying to do here. And then I have an exception as error. So this is kind of the catch-all. If I get an error besides a value error or a 0 division error, it would run this code and again show me the type of error and then the standard error message for that type of error. If there's no exception, then it simply is going to go ahead and do the division properly and show the results. Let's try this. So again, if I do a 0 for my divisor, now I'm getting an error message of the divisor cannot be 0, try again. So I get to specify what that error message is. Let's go back to our 16 and 5. This is going to be our value error, and now I'm told you did not enter an integer value. Try again. And if everything goes fine, then I get to see the results. So we can handle specific types of exceptions. Another type we'll see when we start looking at reading and writing data is an I/O error, when we're trying to maybe read data in from a data file and something's wrong in that data file. And those are really probably the most common, at least in my occurrence, of value errors, zero division errors, and I/O errors. But let me show you can also create your own exception. And this gets into a little more advanced material. I'm not going to necessarily explain all this, but I want to show you what's possible. I'm going to open up another file. And so what I did here, we're going to talk about classes here in a week or two. I created a class called negative integer error, and I'm going to have it take an exception parameter. And then I have something called a def underscore underscore init underscore underscore. This creates an instance of that class. And then I have an underscore underscore str underscore underscore with a parameter of self. That's another function. And this provides output. This will print the error. And so if self.message, if that's true, it's going to print negative integer error, and then what the message is. Otherwise, it'll print a negative integer has been raised. So let me show you my code here. Is I changed this now to enter the dividend as a positive integer. And then I said if x is less than 0, it's a negative integer, I'm going to throw this exception that I've created called a negative integer error. I could have named it a South Mountain error if I wanted. So I chose the name negative integer error. That was the class I created up here. And then I'm raising, or in other languages you might say throwing, a exception of that type. So the message that I'm portraying here is the dividend must be a positive integer. Now I'm going to take this out for just a minute. I'm just going to comment that out. We'll come back and look at that. So I've commented that out. And I'm still handling the other exceptions as normal. This is going to be handled by the except exception clause. Let me just run this. And so it's asking for a positive integer. If I put in the -5, I get an OO, class main negative integer error, and the error message is the dividend must be a positive integer. So it's running this negative error integer error is the type, and then the message is the message that I fed it here. The dividend must be a positive integer. And this was captured then by this exception because I didn't handle it specifically. And so we get that OO, a placeholder 0 error occurred, and that 0 value is the type error, which is a class main class underscore underscore main underscore underscore dot negative integer error. Now let me handle that particular error specifically. Oops. I'm going to say n to discontinue. I'm going to select those 3 lines and I'm going to uncomment. So now I have a piece of code that handles that particular exception, my negative integer error exception that I named. Let's run this again. And notice now I have a print that says error, this program requires a positive integer. So slightly different message. I'm going to run this again. And again, I'll do a -5. And now I get an OO, this program requires a positive integer for the dividend. So I'm getting the message that I specified in handling that particular type of exception. So that's how we can create and throw our own exceptions. Maybe in a testing situation, you might want to do that. Or in this particular operation, we don't want the user to enter a negative number. The operation of dividing a negative number by another number is perfectly fine. I'm just saying that in this particular application, I don't want them to have a negative number. So that's how we can raise an exception and handle it and create our own exceptions, but also then how we handle the standard exceptions that you might come across. If you just jumped into this video and haven't seen the prior videos to this, I invite you to check out my Python playlist of videos. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.